Hi, this is William Thayer. I'm talking about the COVID crisis. This is the third video I'm making. I made a previous video. The first one was testing versus treatment. Treatment, as much as we want it, is not going to stop our problem. Our problem is the spread of COVID. Okay, when I started making these tapes, we were at 500,000 cases. Now we're at 600,000. It's pretty obvious. The problem we've got is the spread of COVID virus. What we got to do is we got to make test machines. That was the purpose of my second video. We got to make 2.7 test machines. In this video is you got to have the sample material that you put into there. You got to have the chemicals that go into the machine so you can do the PCR reaction. Okay, COVID crisis, as I said, I started at this last weekend. It was 500,000 cases. Now we've got 600,000 cases in the US. This is a terrible disaster. 25,000 people dead. Okay. Outline, I've got this in two parts, really, the PCR process and the required ingredients or the elements that go into the sample. That's what the real thrust of this talk is. But a secondary part is in my last talk where I talked about making test machines, I kind of glided right past the part that we need parts, and most of those are plastic. It kind of goes with this talk, so that's why I left it here. Okay, part one, I want to talk about the PCR process because the PCR process is what these test machines use to determine if you are positive or negative for COVID. Okay, the required elements or ingredients or chemicals, whatever you want to call it, that's really the purpose of this talk. So I'm going to use the Abbott COVID test machine as an example. Okay, there's other test machines, of course, but these three little plastic containers, the orange one, the blue one, and the white one, the two on the left contain the chemicals that are needed. Okay, the one on the right contains the sample. It might have some chemicals in there too. I'm not quite sure exactly how they do that. But these three things go in there. The sample, this whole process, cost 40 bucks, which is not cheap, okay? But that will get you a test and tell you whether you got COVID or you're COVID free. Now, the key element to how this machine works, and I've got a video, a reference for videos that explain it much better than I'm going to explain it. I'm an engineer, I'm not a biologist, okay? So, but what's happening here is really a three-step process, and you cycle through and do this three-step process many, many times. So you start up there at the very top, it says genomic DNA. Well, think of that as the COVID strand, the RNA strand. You're going to come down, you're going to make more copies of that. So you come down here to cycle one, it's got 3 steps. You break the strand apart, that's step 1, and step 2 is where the magic happens. You come in there and you have little primers, okay, which are probably A, T, C, and G, these nucleic acids. But you have primers, and then you have a bunch of A, T, C, and G floating around, and those primers start at the top, and they go from on the right side. Starts at the top and goes to the bottom. On the left side, that left strand starts at the bottom and goes to the top. And then when you get in step 3 is you get 2 new strands of this COVID. Okay, and in this whole process, you've got to have an enzyme, that's the polymerase, that acts as a catalyst to make this thing happen. And it may be all in a base. I don't know the details of this. Anyway, so you take these 2, you cycle it again, now you get 4, then you get 8. Okay, that's the part that I understand better because that's the chain reaction part of this. I studied nuclear physics at Stanford, so I ought to know what this is. So we start out with 1 COVID up there at the top. That's the target sequence. By the time we get through the first cycle, we're down. We got 2 COVIDs. Okay, we've duplicated it, and then we go to the next cycle. And we start out with 2, and they split into 2 parts. So we end up with 4 COVIDs. And then we do the same thing again for the third cycle. We end up with 8 COVIDs. That's kind of a nuclear reaction, just like a nuclear bomb, but it's a nuclear biological bomb. Okay, so you go from at the top, you go from 1 to 2 to 4 to 8 to 16 to 32 to 64. You're doubling every step. If you go through about 30 some cycles, you'll end up with 1 billion of these little COVID viruses, which are too small for us to see. We really can't see them in a microscope or anything like that. But 1 billion of them in a solution, you can shine a light on it and you'll get detection. Okay, so 1 billion COVIDs can be detected. Now, what I'm most interested in, though, is how do you make the test samples? The current price is $40. If we want to test 330 million Americans, and I think we do, that's going to cost us $12 billion. Okay, on top of the 12 billion for the machine, 24 billion, reasonable thing. But I think we need to test everybody for 30 days. If we do that, it's 360 billion. Now that's a chunk of money. But can mass production get the price down? I think so. I think so. So I think we could probably get the price down to 10. If we did down to $10 a sample, tested everyone in a day, it would be 3 billion. For a month, it'd be 36 billion. I think we could live with that if what we were getting in exchange was our 2 trillion a month economy. So who can produce these test samples? Biology labs can do it. I have a feeling that the people that do this are probably small little boutique operations, 50 people, 100 people, maybe 1,000 people. They're too small to produce 300 million samples. But we've got big companies that can do this. We've got big chemical companies, DuPont, Dow. We got oil companies. You think of them as oil and natural gas companies, but really they're chemical companies as well. They make lots of polymers. So we got lots of chemists, lots of smart people, Exxon, Chevron, and the other oil companies. So the reason I'm making this video is I've written letters to all the chief executives at Exxon and Chevron suggesting that they do this sort of thing. But if you're looking at this video and you work for Exxon and you want to get back to work, okay, the best thing is to get your company making these test samples, and they are fully capable of doing it. I'm outlining what's required. If we did this, and we tested everybody, we could get everybody back to work, and we could really control the people that were sick. In other words, separate them out, isolate them, and treat them. Everybody else would be getting back to driving cars. Airplanes will fly. Okay, people will be going to restaurants. You will then have your job back again. So what we got to do is we got to make it happen. You've got to make it happen. You got to make your company do this. It's not happening right now. Okay, for those people that want more explanation of the PCR process, you can freeze frame this and look at those links. For the people that want a better explanation of the Abbott test machine, here's a bunch of links. Again, freeze frame it, look at those links. Now, the second part of this talk is making plastic parts. I really spent the most part of my test machine talk on assembling the machines, but we need the parts to do that. So here they are. You can see there's 3 plastic parts outside. There's the machine, and inside it's probably mostly plastic. I bet 100 plastic parts. What we need to do is make the molds and make the plastic. So who can do plastic? Okay, chemical companies can do plastic. I mean, that's where plastic came from. DuPont, Dow, oil companies, Exxon, Chevron, they are really chemical companies as well. And machine companies, machine shops can make the molds if these companies can't. And we got so many machine shops up in Ohio, Wisconsin, and Pennsylvania. And I'm just going to show you one. Here's one. This is from nearly 100 years ago. The guy on the far left is my grandfather. That's William John Williams. He was in charge of this as supervisor for this operation, which was making nails. He later went on to head a foundry, which is making molds. Okay, so we know how to do it. Pittsburgh knows how to do it. I know that for sure. Now, I want to say one more thing here on testing. If we're looking at the charts, this is COVID deaths in New York State. And fortunately, they're headed down. So are the cases. They're headed down. And what we're going to do is we're looking for what time can we reopen. We got to be really careful about that because we could get a second surge easy as pie. We have only tested 3 million out of 330 million Americans as of April 14th. Okay, and yeah, the new cases are going down, and we can look at doing this. But if you're still got COVID people running around in your country, you can get a second surge, and maybe we'll get some help in the summer with warmer temperatures. But this thing will come back and hit us again in the winter. That's why we need testing. There was a big second surge with the Spanish flu. We've got to avoid that. The best way to avoid it is with testing. Now, I think in front of us is going to be China. And I'm thinking they had 80,000 cases. That means 1.2 billion people still haven't had COVID in China. And I think we're going to see a second surge there. So pay attention to that, and let's try to avoid that in the United States. The best way to do that is testing, 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 comprehensive testing. So summarizing, again, I'm going to repeat my theme, which is comprehensive testing is our solution. Treatment, unfortunately, is not. We can make the number of test machines needed, 2.7 million. We can make the test samples. What we need is initiative. We've got to have people that go out there, people like Tesla, okay, that made a ventilator out of auto parts. That's the kind of initiative we need. I'm going to make a future video on, a plan for testing all Americans. Thank you very much for your attention, and stay healthy.